Now let's see the surface modeling. The representation of the complex objects such as the automotive bodies, aircraft bodies, the ship bodies, the blade of impeller, the blade of wings, the casting and the dies cannot be achieved by the wireframe modeling. In such case, the another method of geometric modeling is used known as the surface modeling is used. Now let's see a surface model is generated by using a wireframe entities or curves. Like we have a some this type of shape of object available. Now this if we consider this only the shape, the rectangular, the type of rectangular shape, we can call it as a wireframe modeling. But if we increase the number of wires or we can increase the number of curves, then it be a surface modeling, like in a horizontal and vertical both direction. And similarly, a system may require a one wireframe entities to create a surface of revolution, or it may require two wireframe entities to create a ruled surface, like horizontal surfaces and vertical surfaces. Now, in order to assess the visualization of the surface on a graphic display, the artificially fairing line called as a mesh are added on the surface. Like this curvature or this profile have a 10 by 10 mesh size, the 10 horizontal curves and 10 vertical curves. So the number of curves defined by a mesh size. Now the finer mesh size of the surface require longer CPU time. If we increase the number of curves, or we can say the number of curves, or else say the number of curves, then the shape or this object is very finer for our visualization aspects to construct the surface model and to update the graphic display. So the computational data also increase. If a one curve required a 10 second to computational, then the number of 10 curves required 100 seconds. So if we logically say the number of curves or finer size entities require a more computational time. Now, it is important to note that the finer mesh size for the surface does not improve the mathematical representation. There is no any kind of change for a mathematical representation. It only improves its visualization. For a better visualization, the number of meshes are increased. So our display purpose. Now let's see this object, the conical shape have a 4 by 4 mesh size, and the similar object which have a 10 by 10 mesh size, no, this is have a 20 by 20 mesh size. So we can easily understand and visualize better than this 4 by 4 mesh size. And similarly the second object have a 4 by 4 mesh size and 20 by 20 mesh size. The finer the mesh size, we can easily understand or improve our visualization power compared to this 4 by 4 mesh size. So these are the main difference between the 4 by 4 mesh size and 20 by 20 mesh size. No any type of changes in mathematical improve in mathematical computational, but we can visualize a better increase in mesh size. Now let's see our rendering features. If we need to display our object which is made from which material, like brass, copper, the iron, the stainless steel, so we can easily input a cover, like we need to appear the object appear like a made of stainless steel, then we just need to color that material, that object as a silver. If we need to our object is made from a brass, copper or golden, we just need to color that material, that object as a light yellow, so we can easily understand so the object is made from this material. So this is the rendering feature. Now let's see the advantages of the surface modeling. The complex objects such as the automotive bodies, aircraft bodies, ship bodies, casting and dies which cannot be modeled by the wireframe modeling can be effectively modeled by the surface modeling. So we can use the surface modeling for the complexity curves. If we the complex curves available, we can generate a surface modeling for our better visualization. Now the surface model provide a better visualization as compared to the wireframe models. The surface model of an object is more complete and less ambiguous than the wireframe model. So the confusion is less compared to the wireframe model in surface modeling. With the surface models, it is possible to calculate the properties such as like mass and volume. We can easily calculate that properties. Due to the richness of information, we have a number of parameters available in surface modeling. So the surface model are suitable for engineering applications such as the generating the cross section, interference detection, like in a matting gears, the finite element modeling, and the NC toolpath generation. We can give the example of the NC toolpath in our next slide. Here, the shading of an object is possible in surface modeling. So we can easily detect the shading. Now, the seventh one, the surface modeling is considered as an extension of a wireframe modeling. So the surface modeling is actually extension of a wireframe modeling. If we increase the number of wireframe, then it is converted into the surface modeling. A wireframe model can be extracted from a surface model by deleting all the entities. Like we have that type of conical shape available. This is known as the wireframe modeling. And if we increase the number of curves, the number of profile, then it converted into geometric or the surface modeling. But if we deleted the other one, the curves, then it converted into wireframe modeling. So this line, it's that type of that mint. Now let's see the limitation of surface modeling. The surface model can are more complex, hence require a more CPU time and computer memory for storage compared to the wireframe models. The second one, the surface modeling required more training and mathematical background on the part of the user, and also the sometimes the surface model are awkward to create and require the manipulation of wireframe entities. For example, a surface with holes, it may have to be created with the help of wireframe entities. So somehow we also need the use of the wireframe modeling is better than the surface modeling. Now let's see the NCCNC program. One example of NCCNC program. So this is our component which is made of the as a solid modeling, and the operation is facing to removal of the upper surface of object. So the tool is removing the upper surface of more object by this way. The red lines are act as or display for a retraction path of the tool, and the green lines are represent the tool cutting parameters. So this is NCCNC programming, which the every lines are suggesting, like what is the NCCNC programming, the number of machining we can able to generate by using a software like in our CAM. So you can easily understand in our CAM subject.